what I would like to present here today is, this experience that we have had with the so-called industry academia collaborations. And I'm going to, because I have got 2 monitors, of course, I will look at the camera so that we have the eye contact. And as you can see, the flags there, I've lived in several countries, including these 3 countries. And so I'm a full-time associate professor in university. My area is software engineering. And also, I would say, perhaps about 1 full day of the week, I also work in the role of software consultant as part of my consulting company, which you have the name there, Vahid Software Engineering. So because I like industry academic collaborations that consulting has been, and joint research. So joint research and consulting are 2 of the areas that make me very excited. So I will just spend 1 slide or 2 talk about my background, and also for some of you I have 1 or 2 slides about what is software engineering and what do we do, because some folks think software engineering is just programming. It is much beyond programming and development. And I will talk about my research and my group's research philosophy and approach and experience in industry collaborations. And I think you will like, most of you folks perhaps will like this last part, which is challenges, best practices, and collaboration models for IAC, for industry academic collaborations, because I was looking at actually the homepage of your essentially the grant that you have, Erasmus Plus program that you have got, and I think it's ICT in agriculture. By the way, I worked in Wageningen University in Netherlands for 2 years with Dr. Çağatay Çatal. So that was the connection. So yeah, I worked, but then I decided to move from Netherlands to the UK. Over there, I had some experience, collaborating with other scientists in biology and agriculture as well. A little bit of collaboration in software and ICT, anyways. So just again, not too much about my background, but just kind of I've lived in all these flag areas, as you can see there. And I've been, trained also as a computer science and software engineer, as a master's, PhD, and also undergraduate degrees. And some of the pictures, for my previous talks, and of course, with students, etc. It's very good. Well, I prepared this slide and I presented. I sometimes remind myself of the great people that I have collaborated with. So I want to thank them. Well, they're not in this room, I believe. But so many individuals from industry and academia. So as you can see, these pictures are a mix of industry and academia. Like I would say, 1/3 are industry, and the other portion are academic folks. Again, in those 4 countries. Okay, what is software engineering? By definition, is the systematic application of engineering approaches. So using engineering in development of software. And has different phases and sub areas. We design software systems, we develop them, we test them, we maintain them, we manage them, and we have a process. So as you can see, programming and implementation is just one of the, I would say, 12 areas of software engineering. So it's much beyond. Actually, my own expertise is, I would say, 70% in testing. So I spend more than half of my time in testing and quality assurance in academia and industry, and also I also do a bit of other things, but kind of half of my time is spent on testing and quality assurance, which is an important area, as you can imagine. But also I also like, of course, other topics as well. And what type of questions do we ask ourselves, right? Again, in academia and industry, if you want to work in this SE, software engineering, we say, how can we manage requirements? How can we design software? How can we develop software? How can we test software? And this bullet point you see here is like, in an effective and efficient manner. Those are 2 of the magical and important words for us. It's really that we want to do this with high quality and also with heavy efficiency. And I think it's the same for anything, many other things that human beings are doing, right? If you go in agriculture, I guess, I'm not an agricultural scientist, but my grandfather used to have farms, and I like vegetable gardening and those kind of things myself. So from my very basic knowledge of agriculture, I mean, you want to do the same thing, right? You want your field to give the highest yield each year. And so again, pretty much almost everything that human does here, human beings want to make things effective and efficient. That's kind of most engineering disciplines do, economics and other things also do. Anyways, that's the type of thing that we do. And as you can see, you can imagine there are millions of software engineers across the world working in each country. Motivation for applied research in our area, there are lots of motivations. There was a study by Cambridge University a few years ago that the cost of detecting software defects has risen to $300 billion each year. So that's a very serious, I think that would be almost a GDP of some countries, some small countries. So this is a very serious business. And as you know, I think in the top 15 companies in the world, I think more than half of software companies, Microsoft, Google, Facebook, and all those things. So you can see, and again, lots of software defects in places that you cannot imagine, right? So, for example, Jaguar and Honda and many other brands keep recalling their cars because they have software defects. And very bad things could happen if a car has a software defect, you can imagine. So we need a lot of good work between academia and industry to make these things high quality. What we as researchers do in this area, people like myself, and there are a few thousand researchers like me across the world with software engineering, I'm sure in your areas as well. So we work with software companies to characterize and formalize software engineering practice and challenges. And then we develop approaches to help them develop and test software. That's like, could be me, for example, or any other person. And then these guys build software systems such as now, we are now using Zoom, right? We are using PowerPoint. So every person almost on the planet uses software, right? And on our phone, software, like, on our phone and everywhere. And then from customers, we get feedbacks, etc. And then, of course, we train high quality researchers such as masters and PhD students. And also we publish papers. So that's kind of, and of course, we receive money, hopefully from government or international funds from European Union as well. For example, we also got a very good Horizon 2020, so accepted a few months ago. So I'm actually one of the people in a large Horizon project right now. We collaborate with BMW and a few other companies across Europe, testing automotive systems. So it's software testing of automotive software. That's actually one of the things that. Again, some of the pictures from my past students. This is from Turkey. We had lots of fun and good activities there. Some other colleagues and some students, as you can see. Also from my time in Canada, which I was in Canada for about from 2001 to 2014. Also, lots of activities there. Again, doing lots of joint projects with companies, with partners such as IBM, and also funding and some papers and the startup. I also like startup companies, to commercialize our ideas, which is also very relevant to topic of discussion today. We had one such software, actually, a software that we developed for pipelines to optimize pipeline operations. So, okay. How do myself and my collaborators and group members, we like to do research? I'm sure you know about this terminology, right? Like action research. Have you folks heard about action research? Yes? No? Do we have the chat box? Where is the chat box? Yeah. Okay, chat. Oh, no. Yeah, it's always not easy to. Anyways, I was going to bring the chat box, but it's not easy sometimes to bring it. Yeah, this Zoom software. Okay. Anyways, well, I think I don't mention action research. Action research is that you essentially collaborate with industry. So, action research, again, it's a very quite a terminology that, again, I will, if you haven't heard about it, I suggest you spend later some time to read about it. It's really about applied research, a type of applied research that, and this is actually one of the collaboration models that I very much like. It was published in an IEEE software magazine, a model for technology transfer in practice by some people that I also personally know. So you have the industry and academia on the bottom. You get the problem from industry to work on. So that's a very important point, where to start. So of course, some scientists like to work on very interesting things in academia in theory, but this works differently. It's not, I'm not saying there is no value for that, but in this way of working, since about 2 decades ago, I've been doing, that has been my style, to collaborate with industry, find the problems in industry. Yeah, so you get the problem, you formulate the problem, you study state of the art. This is like a literature review. You work to come up with the candidate solution. You validate it in academia, in the lab, right? The so-called, we check it in the lab, we take it to the industry, we do some validation, and then we do more validation, and then we release the solution. It's a very nice model. I think it works very well if we follow it quite precisely. So most of my projects have been, I mean, formally or informally based on that model. So now, I will mention, I'll talk about very briefly, because I know that some people in the room perhaps may not be in software engineering. So a very high level. So I would say I have had about 12 large research grants with industry. So from some of those projects I will mention, let me just move this aside so that you can see that one. Yeah, this is the new grant that we got. Actually, this should be 21. The project is officially started just in January, the first one. It's called Xandar, which is the acronym. And as you can see, the title is quite long. It's a Horizon 2020. We got it again. We're very good. I mean, we have some partners, Germany, Spain, Greece, Cyprus, and us in the UK. So that's the first grant. The second grant in this list is, again, from there are 8 partners, and so 5 industry and 3 academia. Actually, these projects, as you can see, is more majority is industry, 5 industry and 3 academia. The second one is much, much larger, about 21 million euros. We just finished it in December, about 2 months ago. Another exciting project. This was the so-called ITEA 3. It's IT for Europe. So it's a kind of IT-related funding agency. In Europe, also money comes from national governments. So I was connected to the Turkish side of this project because I used to work in Turkey, so I've got some good connections there as well. So I collaborated, with a large bank in Turkey. The name is Kuwait Turk. Well, it actually means the Kuwait country and Turkey have a joint bank with that name. Anyways, this was the next level of test automation. In software testing, there is a technique called test automation. So we wanted to make it better. 34 partners from across Europe, including Ericsson and many, many large or small companies. So again, very large. And then this is a Turkey. So and then there are a few Turkish projects as well, as you can see there. I also worked with Turkish Aerospace, again, testing, aviation systems, aviation software. So I'm going to present from this Testomat project. Again, the homepage is shown there. Quite a substantial person year, right? 168 person years. If a person would have worked on that project, that taken 168 years. So again, these are kind of more technical testing techniques that we did in this project, and this is some information about the European ITEA consortium. So what we did, actually, I'm gonna play actually a little short YouTube video for you. Let me just put this one there. Well, I will just give you again a very high level idea of what we did, because that may not be too interesting for you, but we want to test systems, right? We want to test web applications and mobile applications, right? You have many web systems, websites, and then mobile apps that we have on our phones. Test these things. Either you can test it manually. Manually means, you go, for example, to your email client, and then, you just, read emails or send emails. You want to manually check if everything's okay. But this is too time consuming and makes us tired to test this. The other way is actually we have other software tools to test other software tools. So you have a software that goes and tests your given software. And then you just sit and relax and watch to see how you find the bugs. Of course, we have to configure and do something to design those test approaches. So that's kind of the cutting edge of software testing. And we developed one approach. By the way, you may say, what did you test it? This was one of them for this Kuwait Turk bank in Turkey, which is a large bank, one of the major banks. We tested their web application, online banking, and also mobile banking. So you can see all the mobile phones are connected to some machines here. And it was like a fun, it would just automatically test these things. You will see that the phones turn on, and then we had designed a scenario that 24 hours, these things were testing our applications. So lots of fun, but of course you have to design it. It won't just happen by magic. That has to be designed properly. I know well, unfortunately, my daughter is there. Good job. Yes. Let's see how then. Sometimes it seems internet is slow, but so anyways, I mean, if internet is too slow, so you can just see that. So we put this, so the right hand side is a website that we want to test. The left hand side is my test software. This is a system that we have developed on the left hand side to test the actual system that I want to test. And it's using something called models. So you design models and graphs of the actual logic, and then you just let it run. You just click the button, and this run, for example, takes about 7 hours to test the entire system. So it takes 7 hours to actually go everywhere and click everywhere and do things. I mean, it's a very, yeah. So you can see a part of that. So we just sit back and let it. I mean, you don't have to watch. I mean, we didn't watch it, but so the system would email you if it finds any issues. But again, this whole technology has to be designed and developed, right? It's not, there are some tools already on the market, but you need to actually do lots of your own work to make this happen. So that was the point. Again, we wrote some very good papers. So as you can see the pictures of some of my collaborators from, this is the Kuwait Turk bank in Turkey, developed, published some papers. This is another company, myself, and also the Saha Information Technologies in Istanbul, and also collaborator from Sweden, Christina University College, a good collaborator of mine as well, Andrea Arcuri. So yeah, and right now also we are publishing more papers as we speak. I'm gonna now present one more project, again, very high level. From my Canadian projects, I've got perhaps 6 or 7 projects in Canada. Just take the number 2. The reason is that it has some very, this project has a very, very far relationship to agriculture. I mean, it's not about agriculture, but this was a company in Canada, very well known, very successful company, developing GPS devices, chips. But their system, their GPS are actually used in, for example, GNSS or GPS for precision agriculture, for many purposes. So their clients were mostly military and agriculture. Why? I mean, again, we all have GPS on our little phone, which are very cheap, not too expensive. These GPS devices are high precision. They would cost about $7,000 for each board. Very precise. It will work inside the room with 10 centimeter precision. So for military and agriculture, that you need very high precision, right? Your telephone GPS will not help you in military or agriculture. So we did another software project for these guys. Again, I think I shouldn't go too much into the detail because, again, I'm not sure about the interest of the audience about the software and detailed things about software. I'm gonna pass these slides. Actually, I was even going to remove it. Well, I will tell you what we did at least. See, well, usually when I go to companies, I say, what is your challenge, right? What are you trying to fix or improve? This company was spending lots of effort and money on developing documentation, software documentation, because software developers write to like documentation, not for users, but for themselves, right? You write a document so that your colleague can understand your code later if she looks at it. few $1 million were spent on documentation, updating them. It wasn't trivial cost. So they wanted to optimize that documentation. So we got about a grant of $300,000 from Canadian government to work on this, some money from the company as well. The solution was that we developed an approach and we tried to help them. It took about 3 years. Again, these are some details of how it was done. What about, assessing costs versus benefits, right? Usually we do lots of cost-benefit analysis in our projects. Again, I'm going to pass through by them, and then we visualize to see for each document how much cost and how much benefit it provides. Again, some good outputs out of that. Again, I like to put the pictures of my co-authors. We published a few good papers in good journals. These are two of the top journals in software engineering. The pictures are shown there. So we assess the usefulness of software documentation. That's a case study. So cost, benefits, quality of documentation. So, okay. So the part of my talk is really almost done. And I went very fast. Well, that's about half an hour. Now, this is, I think, very nice. This is like kind of meta discussions I usually call. Like, we did all this project, so what we understood, what challenges we observed in best practices, and what challenges we observed. I also do some research on these things. I like meta research, research about research. So again, with two colleagues, one of them in Turkey, one in Sweden, we did are you guys familiar with systematic literature reviews, SLR papers, survey papers? Some people call them survey paper, but the systematic ones are called systematic literature review. I'm sure perhaps in your fields also you have SLR papers. I mean, in software, in medicine, social sciences, and also software engineering, people are very passionate about systematic review papers. You read a number of other papers, and then you systematically synthesize their findings, not just putting them together, but connecting to each other. Anyways, that was in 2006, published in 2016. We found 33 other papers in this area, in the area of challenges and best practices for industrial collaborations. Of course, in many other areas, there are many papers in management science, social science, but we looked at all. Any questions? So, but are there any questions? I hope, please feel free to interrupt me in the middle if there's any questions. Okay, so essentially, the chat box is here now. I had brought the chat box, but it was showing under all the other windows. I wasn't able to. Of course, there are no questions. You folks are writing now. The location or your affiliations in different universities. By the way, I like the University of Tuzla. I think also in Istanbul, there is an area of the city called Tuzla. I don't know if those two things are related. One of my friends live in that area of Istanbul, but it's named Tuzla. Anyways, that's on the Asian side of Istanbul, close to one of the large universities there. Okay. So these are, for example, 3 of those 33 papers, right? For example, an author from Ericsson and Chalmers University wrote this paper about agile collaborative research. And then some people from Sweden, Italy, Germany, and a few other places, and then this is from Sweden as well. You see, all the Scandinavians are very passionate about industrial academic collaborations in software engineering, at least. I know of course, I've visited several universities, and I have a few collaborators in Finland and Norway, Sweden. So yeah, I don't know, is that because of their culture or their, what's the reason they are very active talking about these things compared to other countries? I mean, of course, other places people talk about these things, but. So what we did, we kind of took all this data and we synthesized them, right? We kind of mixed them, synthesized the knowledge of findings like by qualitative. I'm not sure if you guys heard about qualitative data analysis or qualitative coding. So by using qualitative data from this, we kind of did thematic analysis and all those things. The findings, some of the findings are here. we categorized the challenges that people have reported in the last 30 years or more about this industry academic collaboration. For example, lack of research relevance from academia. Sometimes it's unfortunate that some researchers work on very interesting stuff, but industry partner does not find it interesting or relevant. It's harsh to say that, but that sometimes occurs. Research methodology issues, lack of training, lack or drop of commitment. Number 4 is very important, and I've observed a few times. Sometimes you have an industry partner or several partners that they are initially interested to collaborate with you. I mean, you attend bi-weekly or weekly meetings. Actually, this morning I had 2 industry meetings with Turkey, I collaborate with Turkish companies. I spent about 3 hours this morning on Zoom meetings with Turkey. Yeah, but fortunately, those guys that collaborate with me, they are still interested. The commitment is still high. We had very productive meeting this morning as well. But sometimes when either side doesn't work very well or that they don't meet each other's expectations, just like friendship, right? Friendship or other types of relationship between human beings, sometimes when you don't see your expectations, that you don't get benefit from it, you say, thank you, but no thank you. I'm not continuing this. So these are very nice, let's say, social issues. I mean relationship related, not social, but I mean about the psychology of how humans and people collaborate with each other. Mismatch between industry and academia. So again, these things were themes that we derived from those 33 studies. So kind of, and some other issues as well. Contractual, right? Sometimes the IP and all those contracts. For example, in our Horizon project that we started last month, things went well, but for IP we had some slight issues. There are some partners such as BMW and a few other German companies. One issue came up a few months ago about the contract, and it took us 2 or 3 months to fix it because they were not giving us the license of the tool, and then there were some issues, but fortunately we found a solution for that. But I have seen projects in which, because of IP issues, the whole project has collapsed or discontinued. So it's very important to be aware of these things. But so best practices are really success pattern or ideas to address these challenges, right? So this is kind of like red or dangerous, and these are good things that you can do. People have reported doing these things. And of course, all the details. I mean, this paper, I think, was a very long paper, so you can read the details there. There are lots of concrete ideas how to do it. Consider and understand industry's needs and goals and problems. Have mutual respect, right? So it looks a bit interesting and funny to say, well, we need to have mutual respect in collaborations. But I've seen again collaborations. I mean, the second fail because of sometimes I will mention something about us academic people. Sometimes we think, well, we know everything, and industry doesn't know too much. That's not correct. So it's about valuing and respecting each other's expertise. Be agile. This is, I'm sure you have heard about plan-driven process. Right? Some people plan too much and they don't do too much work. So planning is good, but you need to actually deliver and do. So again, these are some of the things I wanted to mention. Again, I won't perhaps read through all of them, but but if we do all the things correct, right, we can nicely shake hands, academia and industry, and collaborate. During that also, we kind of, from our experience and also I also had another paper with 2 other industry folks that names are mentioned there, right? I reported my own experience, our experience from doing these collaborations in testing from Canada and Turkey in this particular paper. We also came up with, I'm sure other people also have come up with this. They have tried to visualize the process of industry academic collaborations. Processes. You have the inception phase that you get to know each other. You just talk and you say, well, can we collaborate? What should we do together? Or do we like each other or in a way? And sometimes the initiator is industry academia, right? You go to industry, you say, well, do you want sometimes industry comes to you. Sometimes at the same time, plan it together. And then, well, operational phase, you actually do the actual work. So the output can be you publish papers, right? Scientists and academics, their first priority is usually publishing papers. But for industrial people, they don't care too much. Most of them, they don't have a priority to publish papers. Well, they want to actually develop a system. I mean, in my area, but I'm sure for ICT agriculture as well, you want to use this ICT technology to make something better in agriculture. And then, and then there are challenges, success factors, and anti-patterns. Do you folks know about anti-patterns? What's an anti-pattern? Perhaps I can ask those a question. Do you guys know what is anti-pattern? Any idea? Any suggestions to make this more interactive? No suggestions? Yeah, because I'm just looking at time. I'm not the type of person who wants to present in a very hurry, but I kind of wanted to race against time to make sure I don't go much. So anti-pattern is almost like making mistakes. That's the kind of scientific name, well, in the IT and software domain. And if you search for anti-patterns in Google, you get millions of hits. If you, for example, they say, right, when you say respect each other, it's a pattern. It's something you have to do in academia, industry collaborations. But if we disrespect each other, that's an anti-pattern. So disrespect is an anti-pattern. Something right. Anything that we should things to make these things do certain things because they will hurt the collaboration and relationship. So, anyways, that was the whole point. So I think coming, even with my collaborator in Turkey, which works for a very large governmental company, Havelsan, they develop aviation systems for Turkish Navy, not Navy, just Turkish defense, radar systems, you name it, right? Helicopter simulation. We even published a paper with this topic. I think this may be interesting for many of you to see. We wrote a paper with this name, how to select the right topics for collaborations and testing. So a paper on how to choose a topic for a paper. Again, this may look interesting, but this is kind of methodological meta level. There are many research papers like this even. So again, PhD papers, my all papers can be found in my research gate. There's a number 2, I don't know, there was a number 1. There was some problem with my number 1 research gate. I had to make it number 2. So yeah, we have presented experience-based some guidelines, how you can select the right topics. And there are other people even talk about this. Sometimes you have some industry partner. I mean, for you guys, I don't think that's an issue because you already have a good topic to work on. But sometimes you have a collaborator in industry, you kind of meet somebody from industry. Well, you and that person, you want to collaborate, but you don't know what topic to collaborate on. It may, I mean, sometimes it's laughable, but sometimes this occurs. You talk for a while, but because that topic has to be a specific type of content, you cannot just collaborate on anything. Because if you collaborate on very practical topics, it will not be easy to publish it. I'm not sure if you guys have this experience, but I have an experience. For example, from my consulting projects, I worked on something very practical. There wasn't much scientific novelty behind it. Then you try to write a paper and publish it. Reviewers are not going to accept it. They're going to say, well, this is very practical. There is no scientific novelty. Reject. So those are the issues to consider. There's even another paper by the first author seems also occurs to be Turkish. I think there's a lady I know. She used to be a professor in Sweden. Mısırlı, that's Mısırlı or Mısırlı. They wrote a paper about, they came up with some fitness criteria to choose topics for collaborations: correctness, concreteness, suitability for experimentation, relevance to research committee, prior domain experience, and then you kind of like a rubric, I'm sure You guys are familiar with the Likert scale, like a 0 to 5 or 1 to 5. You put numbers and then you get the average. Whichever gets the high number, you select that for collaboration. So a few of my collaborations, we have done it explicitly, right? So to know that you want to select topics that get high grade in all of these things. For example, we had some candidates in this company, and then we selected those ones. Okay, so that is the end of my presentation. About 30 slides. I hope I didn't go too fast, but I think, yeah, now I will be glad to hear your questions.